In this video we're going to be discussing car batteries and cells, and well, there's a lot to talk about when it comes to car batteries, so I'm going to try to break this down into a few separate videos. In this one I basically want to focus on what's inside a cell, how the cells are combined to make a battery, and some of the terminology you should know and the different types of batteries that you could be exposed to or have to work with. So let's get started. So these two terms sometimes kind of get mixed up and used improperly, so I first want to kind of dispel that. We're going to start with a cell. So a cell is basically one little compartment with all the things that are necessary inside there to make electricity and store electricity as chemical energy. So a cell is basically one little compartment. And in that compartment we're going to find a few key things. We're going to find two dissimilar metals, and an acid. And the acid is going to function as an electrolyte. Basically it's going to make it possible for electricity to flow inside the cell. So one of the most common examples of a cell would be this little thing here, little AAA. We tend to call it a AAA battery, but that's actually an incorrect use of the term. This is a cell. This is one little chamber with two different metals and some electrolyte inside. So we look at this little cell, we look at the side. Maybe you've looked at them before, maybe you haven't. AA is the it's not focusing. There we go. AA is the trade size, and 1.5 volts it says over here. As soon as I get my finger in there, it gets confused. 1.5 volts. So this little cell is capable of making 1.5 volts, and actually a surprising amount of amperage you can get out of a AA battery. We'll come back to that in a little bit. Okay, another example of a cell. Would be these inside this flashlight. So, flashlight here uses two D cells. Together, when you combine multiple cells, you've technically made a battery. So now that is a battery. Of course, you wouldn't say to somebody that your flashlight needs a new battery. You'd probably say it needs two new batteries. And you probably wouldn't say that it needs new cells, because somebody would probably look at you a little funny. But that is the technical correct usage of the term. A cell is one little chamber. And as you learned from reading previously in the homework assignment I gave you in the book, a car battery typically has 6 cells. The batteries are basically just assemblies of cells. And those cells are going to be connected in the battery in series. As we learned during our previous electrical lesson, when you connect things in series, the voltages of those things add up. So in this case, these two D cells at 1.5 volts apiece add up to a total of 3 volts from the negative here to the positive there. So the little bump, I didn't mention yet, the little bump on a AA or a D cell battery, the bump is the positive side and the flat spot is the negative side. So when we connect it positive to negative in a line like that, one path, that's a series circuit. So we have 3 volts here in series. And the reason these make 1.5 volts is the chemistry inside the battery going on there. The actual acid they're using and the two particular dissimilar metals they're using. That kind of contributes to the voltage and the amperage that cell can make. So you can make a cell very easily. Sometimes you do this accidentally. If you've ever put a piece of foil in your mouth and you've got some dental work, you've got metal fillings inside your mouth, well, you have the basic ingredients because you now have two dissimilar metals, whatever metal they use to make the fillings in your teeth, and the foil, and then the acid would be your saliva. Saliva is actually slightly acidic. So to demonstrate this concept, I'm going to take my trusty multimeter here, a little piece of copper wire. I'm going to clip that into my positive lead. Got an old steel screw. I'm going to clip that onto my negative lead. And rather than stick this in my, well, you know what? For you guys, I'll stick it in my mouth and you can actually see what it makes. I'm not doing it on camera though. 0.7 volts. Alright, so we come over here. We'll try this a little more scientifically. I can use a little bit of lime juice out of my fridge. I'm going to try to do this without spilling and on camera so that you can see. So put these in there. Hopefully the wires aren't blocking the view, and looks like we make about the same, 0.8 volts. Hopefully that showed up. So while you can make a cell quite simply, just out of two different metals and acid, it's not practical to make them out of household objects, household chemicals, or saliva and metal objects sticking out of your mouth. The reasons for that should be obvious, but also the fact that it's not going to make an awful lot of current. It can make some voltage, but it's not going to make an awful lot of current. And current, or amperage, as we learned, is actually the flow of electrons in a circuit, and that's actually what's getting the job done, what's doing the work. And in a car, there's a lot of electrical work to be done. First of all, we need to be able to start the engine. Second of all, we need to be able to run lights and accessories when the engine's not running, and there's no alternator to help us out and generate electricity. So we have quite a few reasons to have a battery in the car. Nobody these days wants to go out and hand crank start their car anymore. That kind of fell out of fashion a long time ago. So, in our car batteries, as we read in the chapter, there's 6 cells. And that makes a 12-volt battery, although it's not actually 12 volts. See why in a moment. So if you look closely at a car battery, you might actually be able to faintly make out the cells inside. You can sort of see in the plastic casing, there's little lines in there. And unlike my lousy drawing here would insinuate, they are all the same size as each other. There's 6 identical cells inside that battery. Each one makes 2.116 volts, or 2.1 for short. So when you add 2.1 to 2.1 to 2.1 to 2.1 to 2.1 to 2.1, basically multiplied by 6, you get roughly 12.6 volts. 2.1 times 6. So at one end we're going to have a negative, at the other end we're going to have a positive. And those cells are going to be connected in series in there, just like the batteries in your flashlight or in other electrical items. So each cell has the ability to make 2.1 volts and a certain number of amps. The chemistry that we use in normal car batteries, or what we call a lead acid battery, volts, 2.1 times 6. So this is a lead acid battery. So we're using lead plates, specifically lead peroxide on the positive, and sponge lead on the negative. So those 2 plates are made slightly differently. And sulfuric acid and water. Hopefully my camera's aimed low enough that you can see that. Yep. Well, my writing really slopes off to the right. They say that means you're pessimistic. I don't know what that really means. Could just mean the way I stand at this board while I'm trying to look at the camera too. So the combination of sulfuric acid and water, lead peroxide, and sponge lead plates is going to combine to make about 2.1 volts. That's why that voltage is a little bit higher than the voltage we get out of these type of cells. And there's other types of battery chemistry out there in use. you may have heard of lithium batteries. There's what they call lithium ion, lithium polymer. Nickel metal hydride. That's what we're using in a lot of our hybrids, by the way. Lithium batteries are popular with rechargeable tools right now. Prior to lithium, we used to use nickel and cadmium. And all of those batteries have different pros and cons. They all have obviously different chemistry, and they're going to make different voltages and different amounts of amperage. They're going to have different characteristics as far as how they charge up and how quickly they discharge, so how long they can supply you with current, and exactly how they supply you with current. Some batteries are better at giving you a big surge of high current, but not for long periods of time, whereas other batteries are better at supplying you with a smaller current, but for longer periods of time. So we're going to talk about that as well. Basically, we settled on these lead acid batteries rather than these other technologies for a car battery. And there's a reason for that. So a lead acid battery is very good at high current surges. It's also fairly cheap to produce. One problem with a lead acid battery that you may be aware of is they're heavy. So they're full of lead plates, they weigh a lot, they're kind of dense, and they're full of nasty sulfuric acid. So if they spring a leak somehow, well, and the acid comes out, it's corrosive to metal, it's not good for your skin, it will burn holes in your clothing. A lot of mechanics typically will have holes in their elbows on their shirts from leaning over car batteries. The next time they wash their shirt and take it out of the laundry, they notice there's less material there on the elbows, so that kind of, it's sort of not a good thing when it comes to car batteries. But again, the lead acid battery's been around for a long time, cheap to produce, and still the predominant battery technology we're using in cars, except for hybrids. So this isn't really acceptable for hybrids. We need some different technology there, and you'll be reading about that in the chapter, and I'll be doing a different video on that. Okay. Also going to take a look at my recording time here. All right, doing pretty good. Okay. So, the typical lead acid battery that gives us these high current surges and is cheap to produce is what they call a flooded cell. So basically there's plates inside each of the cells, and they're suspended in some sulfuric acid and water solution. You can actually hear it splash around inside there. And again, they're not spill proof, so they can spill. And that is sort of a drawback to them. You may have heard of something known as an AGM battery. Basically, an AGM is similar to a flooded cell, except they put these little absorbed glass mats that act like sponges in between the plates. So the electrolyte or the acid is basically trapped in those little sponges, and it makes them spill-proof because they can seal the battery. They don't off-gas when they're charging like a regular flooded cell does. And again, we'll talk more about this later on. So this one is spill-proof, but otherwise pretty similar to a flooded cell. There are some AGM batteries that can actually produce a little more current than an equivalent flooded cell. So we're going to write down here, absorbed glass mat. Okay. AGM or absorbed glass mat batteries are very popular with cars where the battery is not under the hood, it's in the passenger compartment somewhere, or it's in the trunk. Because again, it's spill-proof and it doesn't release gases into the area that it's in. They're also popular because of this spill resistance. in off-road vehicles, ATVs, motorcycles, things that are operated at different angles and elevations. So like motorcycles lean way over in corners, and ATVs are operated on rough territory. So AGMs are popular for those applications. There's another type of battery that is spill-proof, and you may have heard of it. People often confuse AGMs with them. It's known as a gel cell, or a gel battery. Basically, a gel cell is not really any different than a flooded cell, except for the electrolyte is not liquid. It doesn't splash around. It's kind of like Jello, like gelatinous. So it has more of a jelly-like electrolyte. So spill-proof, but these tend to not be found in automotive applications. They have a big drawback. They're very fussy about how they're discharged. They don't like really, really high current surges like your starter would be demanding of them, and they have to be charged kind of carefully. They need a very steady, continuous amount of charging current, and that's not really how the alternator and the charging system in an automobile works. So they're not really good for automotive use. You find them in things like Power Wheels, little Jeeps and cars that you charge up for kids to ride around on. You find them in emergency lights that you see up on the walls and hallways and things like that in public buildings. They come on when the power goes out. Basically anywhere you need a decent amount of current that a flooded cell could give you, but you don't want it to spill. Spill proof, but not well suited to cars. Again, some people will confuse an AGM with a gel cell. They'll call it a gel battery, but it's really not. The confusion comes from the fact that the AGM is also spill proof. So, need to talk about charging and discharging a little bit. And I think that's going to be just about it for this video. So I'm going to oversimplify this greatly. Hopefully I have enough markers. Here we go. So, here's my container. Going to be my positive plate. The blue marker died, so you're going to have to settle for purple. This is going to be my negative plate. And we're going to pour some electrolyte in here. Positive plate. So when they build this battery, they build certain chemistry into the plates. As I said, the positive plate is lead peroxide and the negative plate is sponge lead. They fill it with electrolyte and it will almost immediately start to have a bit of a charge. When they hook this up to an electrical source and apply current to it, so basically they'll have a battery charger that's plugged into the wall. They'll connect leads, one to the negative, one to the positive. That's going to increase the charge in there. And basically what's happening, not to get into the chemistry aspect of it, because nobody really wants to know the chemistry, they're going to force extra electrons off of the positive plate through the electrolyte until they build up on the negative plate. So as we learned back during basic electricity, electrons are negatively charged particles. When you take an electron away from an atom, you leave behind a hole. And this imbalance is the voltage that the battery can produce. So once that battery is charged, we can remove the power source, and that imbalance is going to stay there until I connect the load or connect the circuit. When I connect the circuit, like if I just put a wire from one side to the other, that would be a short circuit, as we also learned. A circuit without a load is a short circuit. Those electrons will flow over to the positive plate to try to get into those holes and equalize the imbalances. So when we do that, hopefully not with a short circuit, hopefully with some kind of load, like a light bulb, that's going to be known as discharging. So all batteries are meant to be discharged. That's the reason we have a battery, is so we can get some electrical current. So the battery makes current, and it can also store current. So the batteries that we use for automotive purposes are rechargeable. Now, not all batteries are rechargeable. So here's a little battery here that you might be familiar with. Very common in household applications. Here's our 9-volt battery. Common in smoke detectors, guitar pedals, things like that. This can't be recharged. Its chemistry doesn't allow for it. But in a flooded cell, the chemistry does allow for it. And you're recharging that battery continuously as you drive the car. That's being done by the alternator. So one thing I should point out right now, when this is being charged and you're replenishing that charge, you're building up that imbalance. So either by the alternator as you drive, or a battery charger in the shop. The chemical reaction that's going to take place inside this battery is going to cause the battery to produce hydrogen gas. Hydrogen gas is going to come up out of the battery. For that reason, flooded cell batteries are vented. There are vents on the top of the battery. We have to let that hydrogen gas get out. Produces hydrogen gas. And the reason I'm making a big deal out of it is, if you didn't know already, hydrogen gas is extremely flammable. So sparks near a battery, like you dropping a wrench across the two terminals, can cause the battery to explode. And nobody wants a car battery to explode near them. It's loud, it's, well, there's flames, and there's acid and plastic pieces flying everywhere. So that's not good. If you weren't wearing your safety glasses, you'd have acid in your eyes and possibly permanent eye damage. So you always want to wear glasses when around batteries. A lot of techs like to wear rubber gloves when around batteries, not only because of the acid, but because of the lead in the plates. Lead, as you know, is poisonous. So just some precautions to be taken. And I think I'm just about out of time in this video. I'm hoping when I get around the other side of the camera to turn it off, I don't find that it's already stopped. But that's basically what I wanted to cover. The plates inside the cells inside the battery in series to build up to the required voltage, and the charging and discharging. So charging when we hook up a power source and build up our charge in the battery, and discharging when we're using the power from the battery to actually do something useful. And then of course the hydrogen gas produced when it's charging, so we have to be cautious of that. That's one of the reasons you never leave a battery on a charger unattended. You wouldn't want to go home overnight with a battery in the shop on a battery charger, so don't ever do that. Alright, so this is our first video. There'll be more to come. So tomorrow, when we do this video, I'm going to talk to you about deep cycle batteries and SLI batteries, and some of the differences there, and we're going to get into multi-battery connections, why some vehicles have more than one battery. So stay tuned. Hope you enjoyed this video, and I'll talk to you soon.